When we last left off, we had our averages program, which we modified to use a counter-controlled loop, which then lets the user input however many integers he or she or z might want to test, and then from that collects the average. And the problem that we ran into was if the user says that they want to test 0 integers, or if they want to test -5 integers or something like that, our program doesn't quite work correctly. And so what we're going to learn now is the second type of loop structure, the Sentinel controlled loop, which is sometimes called indefinite repetition, which will help us solve this particular problem and make our program better. So Sentinel controlled loops basically keep looping until some condition is met. And the difference between a Sentinel controlled loop and a counter controlled loop is that with Sentinel controlled loops we usually don't keep track of how many times this has happened. Sometimes we do, but usually it doesn't matter so much. In Sentinel controlled loops, one of the things that we do with them is we use them for input validation. We do a lot of different things with them. Okay, so this is a Sentinel controlled loop. Okay, we're going to ask the user for a number between 1 and 10. We'll collect that number, and then while the number is greater than 10 or less than 1, we tell the user to try again. Then we collect our next number, check to see if it's greater than 10 or less than 1, and we keep going and going and going and going and going. Okay, so let me show you real fast what this looks like. Okay, so here's our code sample. We create a scanner. We ask the user for a number between 1 and 10. We collect that number. Then while num is greater than 10 or num is less than 1, remember that with the condition, that's those are the circumstances under which we want to keep looping. Right? If the user enters a good number, we don't want to keep looping. We want to stop right there. If the user enters a bad number, though, that's when we want to prompt again. System out, not print, nope. Try again. And then num is equal to n dot next int. Then we roll from there. Okay? And that'll just keep going so long as the user keeps entering bad numbers. Let's see it in action real fast. Okay? So we'll ask the user for a number between 1 and 10. Let's first make sure it works in positive conditions. Let's try 5, which we know is a number between 1 and 10. It'll tell us good job, so that's good. Now let's try 0, and 15, and -7, and 23, and 100, and 121, and 144, -169, positive 225, and so on. We skipped 14 squared there. That's 196, but yeah. And then from here, finally, we'll hit a 4. It's a good job. And the really cool thing about the Sentinel controlled loop is it just keeps going. It's very patient. One of the a problem that we might have run into in the past with using if statements would be that you have to write to collect input. Like we might have an if statement that checks to see if the number is between 1 and 10, and then another if statement that sees if the new number is between 1 and 10. But we have to have a new if statement every time we want that to happen. So eventually we're going to run out. And what happens if our user is just really, 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 really bad at things? Whereas if we do it with a Sentinel controlled loop, like so, this while loop right here, and very specifically that condition where we check to see if the number is bad, like that's what we're checking right here. We're checking to see if our number is bad. And so when we do that, what that lets us do is basically go indefinitely. Okay, that's pretty cool. There are a couple of pitfalls that I want to show you with the Sentinel controlled loop before we move on too much further. But once I show you those pitfalls, we'll be ready to go back and modify our original program. Okay. Now, Sentinel controlled loops. Again, this is where almost all the pitfalls come in. Is making sure that our Boolean condition defines when the loop should keep going rather than when it stops. So our Boolean condition, that's like this user n is greater than 10 or user n is less than 1. Anytime we have a number that's bigger than 10 or less than 1, then we have a number that is not between 1 and 10. And so that's when we should keep going. So a Boolean condition is usually like, while this statement is true, the user is doing something we don't want them to do. And as soon as the user does something that we do want them to do, we stop. Okay? So we'll come back and modify our program here in a second. But first I want to show you a couple of problems that we might run into. The first one, right? So enter a number from 1 to 10. And then int user n is equal to n.nextInt, so that's all fine. And then while user n is greater than 10 and user n is less than 1, we try again. Now the problem here is that there exists no number this description is actually incorrect. The problem here is that there exists no number that is simultaneously greater than 10 and less than 1. So this loop will never enter. We can't use it at all. There's no way that it'll happen. Okay. Now the second problem, this is another way that this might work. Let's say that we want, well, user n is less than 10 or user n is greater than 1. Now with this problem, if the user inputs, let's say a 5, that is less than 10 and greater than 1, so it'll keep going. If the user inputs a 0, it's less than 10, though it's not greater than 1, but because we're using a logical OR here, that'll keep going. And if we input, say, 100, it's not less than 10, but it is greater than 1, so this will keep going, which means that this particular loop will go infinite. It'll continue forever. There's no way that we can possibly exit out of this loop without stopping our program entirely. This loop will go forever. It'll be an infinite loop, and that'll be a problem. That'll probably frustrate our users sooner or later. Okay, before we go too much further with all of this, let's go back and write the rest of our program. Okay, so we'll save and quit, clear the screen, and we'll open this up. And now the thing that we want to muck with, so to speak, is this section right here. All right, we want to make sure that our end value is at least 1, let's say, because if you take the average of only one number, that just ends up being that number. Actually, so let's say we take the maybe we just make sure that it's at least 0. Okay, and so the way that'll work is while end value is less than 1, since we can't take the average of 0 numbers and we can't take the average of -5 numbers, system.out.print must be greater than 0. Okay? Try again. And then from here, end value is equal to n.nextInt. And we stop right there. Okay? So we prompt our user, we collect our end value, and then we validate it. And if our end value is bad, we ask again. And then we ask again, and then we ask again, and then we ask again, and so on, and so on, and so on, until the user gets it right. Okay? So here's here's what we've run into. And when we work it this way, what'll end up happening is it'll run just the way that it should. Okay? So we'll compile, then we'll run. So how many numbers do we want to average? Let's first do 3, just to make sure it works. We go 1, 2, and 3, and our average is 2. Now let's say that we want to average 0 numbers. I'll say must be greater than 0, try again. Let's say we want to average -10 numbers, must be greater than 0, try again. We'll just average 5 numbers. That'll be 1, 2, 3, 4, and 5. That'll give us an average of 3 in this particular case. Okay, so it works. And the way this works, again, is we just have this Sentinel controlled structure that does some input validation. We just make sure that it works. And then once we have the input validation, once we know where our end value is, we have another structure. This is our counter controlled structure that does the actual work of collecting that many numbers and then averaging them all together. So that's pretty exciting. That's how this whole thing works. When we come back, I'm going to show you real briefly what a hybrid loop looks like, which is a combination of the counter controlled and Sentinel controlled, and then we'll wrap up. The important thing right now, again, isn't so much that you're able to write all of these loops. It's mostly that you start thinking in these terms. As we progress through the semester, as we progress over the next couple of weeks, you'll get a lot better at writing loops and at learning how to write loops. For right now, though, I just want you to see how some of this stuff works. See you in a second.